Hello, so my name is Bryce Cannon, and I'm an applied physics PhD student here at NJIT, and I would like to talk about spheres of the solar system. To overview, I'll start talking about Earth's atmosphere. I'll talk about the magnetosphere, which is around Earth, and then I'll talk about the Sun's atmosphere, and I'll talk about the heliosphere, which is around the Sun. So with Earth's atmosphere, the temperature varies with height. The temperature is shown on this horizontal axis here, and the height or altitude is shown on the vertical axis. And we see on the red line, sometimes the temperature decreases with height, sometimes it increases with height. And the borders between increasing and decreasing will separate out the different layers of the Earth's atmosphere. There's going to be 5 layers like this. And with these 5 layers, I'm talking about just electrically neutral particles like nitrogen molecules and oxygen molecules, ozone molecules, that kind of thing. No charge. The first layer is called the troposphere. Here, temperature will decrease with height because Earth will transfer its heat into the atmosphere. So it's being heated from below by the Earth's surface. It's called the troposphere because tropos means change or turn, and it's home to weather, which changes frequently. And this is the densest layer of the Earth's atmosphere, containing 3/4 of the Earth's mass, the atmosphere's mass. The next layer up is the stratosphere. Here, temperature increases with height because ozone absorbs UV radiation from above. So the topmost layer of the stratosphere can see the most UV radiation and get heated by it, and by the time you get to the bottom, there's less UV radiation, and so it absorbs less and gets less hot from that. It's the home to the ozone layer. This is where it gets its name, the stratosphere, strat meaning layer, and it has a layer within it called the ozone layer. So it's a layer within a layer. That's why it's called the stratosphere. The next layer up is the mesosphere. Here, temperature decreases with height, just like the thermosphere. Instead of being heated from below by the Earth, though, it's being heated from below by the stratosphere. It's called the mesosphere because it's the middle layer, the third of the 5 layers of the atmosphere. And this has the coldest place in the entire Earth system. The top of the mesosphere, everything below it is hotter, and everything above it is also hotter. The mesosphere is also the home to where meteors shine. Meteors are, I guess it should be, the meteors are what it's called when it's in the air still. So this rock coming from space is running into enough air. The mesosphere is dense enough to heat this up and make it bright so you can see it as a shooting star. The next layer up is the thermosphere. Here, temperature again increases with height like the stratosphere. Instead of just absorbing UV radiation, though, this is due to absorbing X-ray and UV radiation. So at the top of the thermosphere, it sees all of the X-ray and UV radiation. And by the time you get lower, there's less X-ray and UV radiation to be seen. And so it doesn't get as hot. Now the thermosphere is called this because thermo means heat, and it's pretty hot. It's 2,500 degrees Celsius. But it can't really heat up things because it has very, very low density. And so it's going to have very, very little heat conduction. So the International Space Station, which lives in the thermosphere, can't really get heated up by the thermosphere. It can't come into thermal equilibrium with it because it has such low density. Now the thermosphere is also home to auroras. The last layer is called the exosphere, and here exo meaning outside, it's the outermost layer. Here particles can escape into space. Particles that are going fast enough will just escape right into space. These particles in the air, they rarely collide with each other. They go on what's called a ballistic trajectory, or like a little arc trajectory, instead of ping-ponging off of each other constantly, like in the other layers of the atmosphere. The exosphere contains many satellites live in this layer of the atmosphere. The ionosphere is not a distinct layer of the atmosphere like the ones we were talking about. It overlaps the meso and the thermo and exospheres. And what makes it the ionosphere is that it's composed of ions, charged particles. Solar radiation can rip electrons off of neutral particles and turn them into charged particles, ions. This ionosphere doesn't have a fixed thickness. It's dynamically growing and shrinking, and it contains the auroras. And the size of the ionosphere is affected by space weather and terrestrial weather, and it's dynamic. Okay, so to overview the Earth's atmosphere, you can pause the video now and try to guess what the layers are. 3, 2, 1. So the lowest layer is the troposphere or weather sphere, where the temperature is decreasing with height. Next we have the stratosphere or layer sphere, which contains the ozone layer, and the temperature increases with height. Next we have the middle sphere or mesosphere, where again temperature decreases with height. Then we have the thermosphere or heat sphere, where temperature increases with height again. And then the outer sphere or exosphere, where the particles can escape into space. Okay, so next I want to talk about the magnetosphere. What is that? That's the region around a planet that's dominated by the planet's magnetic field. So other planets also have magnetospheres, but I'm going to focus on Earth's magnetosphere, which protects life on Earth and protects our atmosphere from being stripped away by the solar wind. So here in this picture we have the sun. These blue lines represent the solar wind, these particles streaming out constantly from the sun. And this comet shape, or this bubble shape, that's the Earth's magnetosphere, protecting the Earth. The magnetosphere is, as you see in this picture, not actually a sphere. The side, on the day side of Earth, the day side of the magnetosphere is compressed. The night side is stretched out into a magnetotail. The inner magnetosphere is called the plasmasphere. They're the same thing. Inner magnetosphere is the same thing as the plasmasphere. The plasmasphere is not actually a sphere, it's a donut shape. The ionosphere was actually a sphere, shown here in yellow, and outside of that is the plasmasphere in blue. And so because of Earth's rotation, one side is called the dawn side, where the sun is rising, and the other side is called the dusk side, where the sun is setting. We're looking here straight on, coming like from the sun, looking at Earth. And the dusk side of the plasmasphere has a bit of a bigger bulge on it than the dawn side. The plasma pause separates the plasmasphere from the outer magnetosphere. And what's physically important about the plasma pause is that the plasma is 10 times denser inside the plasmasphere as outside. So that's the physical reason for separating it into two different regions. The outer magnetosphere is in between this plasma pause, and the outer boundary is called the magnetopause. And what's physically important about the magnetopause is that's where these pressures balance. So there's a pressure of the magnetic field of Earth coming from inside, and there's a pressure from the solar wind on the outside. And where those two places balance, that's called the magnetopause. That's what's physically important about that boundary. The outer magnetosphere is not a sphere. The night side extends back as a shape called the magnetotail, and the sun side, the day side of the magnetosphere is compressed. Outside of the magnetopause is a region called the magnetosheath. And the outer boundary of the magnetosheath is called the bow shock. Bow like the bow of a boat. And the solar wind coming from the sun, when it crosses the bow shock, it gets much slower. This is the place where the speed of the solar wind abruptly drops. Slower inside the magnetosheath than outside in the interplanetary space. So to overview the magnetosphere, you can pause the video now and see what these labels mean. This is labeling this light blue region. This is labeling this other blue region. This is labeling the boundary in purple right here. And this is labeling this entire region. This is labeling this blue region, and then this is labeling this white boundary. Okay, so to overview, I've put in rainbow order the different parts of the magnetosphere from red down to purple. So the plasmasphere, or inner magnetosphere, is dense and is just outside the ionosphere. The magnetopause is the boundary where pressures balance. It's the outer boundary of the magnetosphere. The magnetosheath is a region that's just outside of the magnetopause boundary. And the bow shock is where the wind speed drops. And that's what the outer boundary of the magnetosheath. So we've talked about the Earth a lot. Next we're going to talk about the Sun. So the Sun has an atmosphere. Again, the temperature, kind of like in the Earth's atmosphere, the temperature varies with height. So here again we have temperature on the horizontal axis, altitude on the vertical axis. And sometimes the temperature decreases, and sometimes the temperature increases. Sometimes the temperature increases very quickly. And so these are going to define our three layers of the Sun's atmosphere: the photosphere, chromosphere, and corona. So the photosphere is not very dense. It's about 0.01% as dense as Earth's atmosphere. It is the visible and opaque layer of the Sun. That's where it gets its name, photo meaning light. It's the visible layer of the Sun. It's absorbing light from below. So the inner part of the Sun lets loose a bunch of light, and that gets absorbed in this opaque layer. It's not very thick. It's only 100 to 400 kilometers thick, and its temperature is 5,800 Kelvin. So the surface of the Sun is about 6,000 Kelvin. The next layer up is called the chromosphere. It's even less dense, 0.01% as dense as the photosphere, which was already 0.01% as dense as Earth's atmosphere. It's seen as red during a solar eclipse. Chromo means color, and that's where it gets its name, the color sphere, from this red color. Here the moon is covering up the Sun, and you can see red on the outside. It is thicker than the photosphere. It's 1,500 kilometers thick. And here the temperature drops from that 5,800 Kelvin down to 4,000 Kelvin, and then rises up to 10 to 25,000 Kelvin. In between the chromosphere and the corona is a very thin transition region where the temperature transitions from 20,000 Kelvin all the way up to 1 million Kelvin. It's a difficult layer to see. The hydrogen is all ionized. So to see it, you often look in wavelengths of different ions, like the carbon-4 ion. Can see it like this in this picture. It sees stuff that's around 100,000 degrees Celsius. And the uppermost layer of the Sun's atmosphere is called the corona. So the top layer, corona, means crown. And it's even less dense, 0.01% the density of the chromosphere, which was already 0.01% as dense as the photosphere, which was already 0.01% as dense as the Earth's atmosphere. It's the hottest layer of the Sun's atmosphere, 1 to 3 million Kelvin, and it's unclear why this layer of the atmosphere is so hot, scientists are trying to solve what's called the coronal heating problem to understand why it's so hot. This is what produces the solar wind. The solar wind is a constant stream of particles coming from the sun, coming from specifically the corona. We've talked about the layers of the sun's atmosphere. Next, I want to talk about the region around the sun where solar wind has a significant influence, which is called the heliosphere. There's not a sphere shape, it's more like a comet shape. It's like a bubble that's being inflated by the solar wind. And outside of the heliosphere would be called the interstellar medium, the medium in between stars of the Milky Way. And this heliosphere is mainly studied by two satellites called Voyager 1 and Voyager 2. Okay, so let's learn about the parts of the heliosphere. There's an important border called the termination shock, and this border is when the solar wind coming from the sun slows down to speeds that are subsonic, or slower than the speed of sound. It's kind of like water pouring into a sink, where the water impacts the sink, that's like kind of like the sun, and the water flowing out is like the solar wind. And at first, the water is going very fast, and it's going faster than the speed of a water wave, so it's supersonic here. And then there's a shock front where the water gets slower, and it looks very different. And you can see the waves on it, and it's more turbulent waves right there. So that region, that boundary is called the termination shock. The heliosheath is between the termination shock and the outer boundary called the heliopause. So the heliosheath has turbulent wind, slower wind than within the termination shock. Now, we talked about the magnetosheath and the magnetopause before, and now I'm introducing the heliosheath and the heliopause. So just to be clear, the magnetosheath is beyond the magnetopause, but the heliopause is beyond the heliosheath. So it's kind of reversed from before. Now the outer boundary, this is called the heliopause. And what's physically important about the heliopause is that it's where the solar wind's pressure balances the pressure of the interstellar medium. The medium in between stars, the plasma in between stars, that has a pressure, and so does the solar wind, and where those pressures balance is called the heliopause. Again, I don't want you to get confused about the ordering of pause and sheath. So the heliopause is beyond the heliosheath, but the magnetopause is closer than the magnetosheath. Alright. And finally, we're getting to astrospheres, which are heliospheres around stars other than the sun. So here you can see this bubble around Ella Orionis. It has its own solar wind blowing up its astrosphere. And here BZ-Chem, you can see its astrosphere, and you can see Mira's astrosphere here in ultraviolet wavelengths. Okay, so to overview the heliosphere, you can pause the video now and guess what this label is. This is labeling this border right here. This is labeling this turquoise region, and this is labeling this boundary, and this is labeling the entire thing. And try to guess what each of them means. So the entire thing is called the heliosphere. The outermost boundary is called the heliopause. This turquoise region is called the heliosheath, and this boundary is called the termination shock. Thank you for your time. Hope you guys learned something. Let me know if you have any questions.